We have two types of angles up here. We have the central angle and the inscribed. The central angle has the vertex at the center. For the most part, we'll be working with a central angle. Inscribed angles have their vertex on the circle. Circles and arcs. So this segment goes from the center to the circle is called a radius. This is a segment that touches a circle at 2 points. And the diameter is a special type of chord. It's made up of 2 radii. Notice singular is 1 radius, plural is 2 radii. The diameter is twice the radius. Arcs are the ones you see out here. This is arc AB, and it's cut out by angle, the sides of angle C, which is the central angle. And how do you name an arc? You draw a picture of an arc. This is arc AB. And it's a minor arc because if you were to measure its central angle, its companion central angle, it's less than 180 degrees. Angle C is a central angle. If you go the other way around from A to D to B, you would call that a major arc. So this is major arc ADB. Notice I use 3 letters for that. It's greater than 180 degrees. The central angle measurement and the arc it cuts out have the same measurement. So if this was 50 degrees, the angle C, arc AB would be 50 degrees also. Parallel lines never intersect. They have the same steepness and slope. This is a symbol for parallel. So you forget how to write parallel, you can use this symbol. Line 1 is parallel to line 2. Perpendicular lines form 90-degree angles. 90-degree angles and perpendicular go together. Where you find one, you find the other. If you have a perpendicular lines, you have 90 degrees. If there's a 90-degree angle, there are perpendicular lines. A dihedral angle, notice how it's spelled. Dihedral angle is the angle between planes. Here's an example. They want us to find the value of x and y. So you look at the drawing and you start picking things up. For example, if you were to go from this side of the line to the other side of the line, that would be 180 degrees. So angle, the value that goes for this angle plus 90 plus the angle, the value of this angle, you put them together, would be 180. This little square means 90 degrees. They also tell us that angle x, or the degrees for this angle, x, is 1/3 the measurement of the degrees for this angle, which is y. So you write the first equation where the sum equals 180, x plus 90 plus y equals 180. And then notice you have x and y, but we're going to go ahead and be able to substitute the x for 1/3 y. And like that, you have one type of variable and you could solve for it. So you do your algebra by moving numbers away from the variable y. So you move the 90 by subtracting. And you come back to the 4/3 by multiplying both sides by the reciprocal. The reciprocal of 4/3 is 3/4. Now you multiply this and you get y having a value of 67.5 degrees. Now that you found the y, you could use that formula we mentioned before. And now that you know the y, you could substitute for this y and continue. And with this, you could find x equaling 22.5 degrees. There's some more terms. Each of these is called a simple curve. Simple curves intersect itself at the beginning, at the end. That's the only places it intersects. Closed curves begin and end at the same point. More terms, a polygon is a simple closed curve with only segments as sides. So this is an example of a polygon. Notice it's a closed curve but the sides are all segments. This is also a closed curve. Notice the difference between these two. This one's like caved in. This is called a concave curve. And this one's called a convex. Convex, concave. Now, when we name polygons, we name them because of the number of angles or sides. So if the polygon has 3 sides, we call it a triangle. If the polygon has 4 sides, we call it a quadrilateral. If it has 5 sides, you call it a pentagon. But notice this is going to go on indefinitely. So what do you call one that has 1,000 sides? Well, we're going to run out of names, so we'd rather do it a different way. Naming polygons. You're going to run out of names. Therefore, instead of giving them a name, name them this way. If it has 257 sides, call it a 257 gon.